In this video, we will connect to and visualize IBM Cloudant data in Tableau using the CData ODBC Driver. Let's start by exploring the data in our IBM Cloudant NoSQL database. For this video, we've replicated a primer dataset with restaurant information. The bulk of the data is stored in nested JSON objects, including an object for the address information and an array for a series of grades for the restaurant. Note that within the address object, we have some coordinate information and that there is datetime information nested within the array of grades. The CData driver is able to drill down into the nested data to enable powerful analytics on all the data. To connect to Cloudant NoSQL data in Tableau, we need to configure a DSN using the ODBC driver. We've used the credentials for our instance to authenticate, and we've configured the driver to flatten any objects and arrays that it encounters as the data is parsed. With flatten arrays set to 10, the driver will create a column or columns for the first 10 objects in an array. Because we're connecting as an ODBC data source, our connection is live, providing options for real-time self-service analytics. I've loaded a pre-built Tableau dashboard with visualizations based on the Cloudant data. We'll switch to a specific sheet in order to see the dimensions and measures that are exposed. Note that the address object has been parsed into its parts, and even the coordinate array has been parsed into two separate values. You can also see that the fields of each element in the grades array have been parsed into appropriate dimensions and measures. We can even see that Tableau sees the date field as a date value, even though JSON has no inherent date type. This is thanks to intelligent data typing by the CData driver using dynamic metadata discovery. As we move back to the dashboard, let's start with the map visualizations. Tableau is able to plot data points and regions based on location information, which we have access to thanks to the CData driver's ability to parse nested data. On top, we have a map of all restaurants, colored by the borough characteristic, where you can see the name, cuisine, and average score information for each restaurant in the tooltip. Below that, we have a heat map based on the average score by zip code. Green zip codes have the best average score, yellow zip codes have the worst. The next visualization we'll look at is a stacked bar chart showing the number of each letter grade received by a restaurant in a given borough. Building such a chart requires the aggregation of data. In order to reduce the burden on tools and local resources, CData drivers are able to push complex aggregation queries down to the data source to be processed server-side, as long as the client supports live connections to data like Tableau does. Last, we have a line chart that maps the average score for all restaurants grouped by the borough. Without the ability to drill down into the grades array and report the date field as a datetime value, this kind of visualization would require more integration work or client-side calculations. With the CData drivers, this functionality is available immediately out of the box. Tableau is able to connect to live data through ODBC drivers, and when paired with the CData drivers, users are able to quickly visualize and perform self-service analytics on data from more than 100 SAS, big data, and NoSQL sources. If you have any questions, contact our support team by emailing support@cdata.com. You can download a free 30-day trial of any of our drivers from cdata.com and see the CData difference for yourself. Thanks for watching and have a great day.